Good afternoon, everyone. It's a pleasure to be here. My name is Salah Sukkarieh. I'm from the University of Sydney in Australia, and I'll be talking to you about a particular robot, which you can see over there if you're interested later to come and have a chat about the work that we're doing, and especially trying to support smallholder farmers around the world. My background is on two levels. One is on agri-robotics, and for the last 20 years we've been building solar electric robots to work on farm, on different types of farm, vegetable farms, tree crops, grazing livestock, and even grains as well. So that's one part of my activity. So how do we build these robots to work on farm and do things like weeding and spraying? And another part is to, when all this information is being collected by the robots, what can we do with that information and how do we support the farmer in delivering that information to them? Okay. Despite what we've done, so we've done lots of different robots. We've been able to demonstrate it in different farms across Australia as well as in different parts of the Indo-Pacific. So we've been fortunate to be able to do that and be able to present that work in that way. But despite what we've done in terms of all, we find that all the farmers generally have the same problems. There's lack of labour availability, or labour is very high in cost. They want to reduce chemicals, and that's an important part. But they also need more and more information about what's happening with their plants, pests and diseases, etc. So there's been various elements there about trying to work with different types of scales of farmers, large farmers, medium farmers, small farmers, all having the same problems, and that's changed the way we've developed the technology and their different forms. So one part is with the mid-sized farmers, so that's about 40, 50 hectares of land, and they might do 2 to 3 crop rotations. You can see there on the top, so the slight greens is probably not working in laser, but the top left there is the first robot that we built, which was called Ladybird. It can operate for about 8 hours, solar electric, collect data, and also do some weeding. The farmers really enjoyed it. It was a research platform. They then asked us to build an operational platform. So the middle robot that you see there is Ripper. That could operate for 24 hours, 7 days a week. It was solar electric. All the sensors were on board and it could collect information. And we got so much attention from that that we then commercialized the platform. So the platform that you see on the right is a commercial platform that operates around Australia, being able to do various things such as, again, collecting data and doing weeding and spraying. In addition to the robotic platforms, we've been able to build some digital tools, being able to do things like detecting weeds and detecting plants, detecting the size of the plant so we can do yield estimation is another one, and then being able to present the information to the farmer, how many plants they have, where the anomalies are, so where plants aren't working properly, for example, they're not growing properly, the growth of the plants and also the weeds and so forth. So that presents us all that information together. But in addition to the mid-sized farmers, we've been also working with the small-scale farmers. So these are farmers that are 1 hectare or less, and being able to build the technology in a way that helps them. And this is what I'm going to be talking about mainly in this presentation around that work. One of the first demonstrations that we had was building a very simple platform, almost like a drone, but on the ground, that could operate for about 3 hours and collect information about the plants that were going on there. And then the second extension to that was being able to add a hitch mechanism onto the back so we could add some tools, and I'll talk a little bit about that. And then being able to extend the battery life as well, so we can get about 8 hours of battery life on the more scale. So that was kind of the evolution, and I'm going to be talking about the evolution and the experiences that we had in the Indo-Pacific on that platform. And in addition to that, we want to be able to do crop intelligence, so be able to understand pests and diseases, and there's been an evolution of that activity as well. So our first goal was to build a platform that was reliable, that was low cost, and that could actually deliver some information. So this was the first platform that we built, which was called the die wheel. Inside the wheels is where the batteries and the electronics are, and that stabilizes the platform as it's going up and down. And it was meant to be easy to build, easy to use. So you could see there it's very stable in terms of its wheel. In about 15 minutes, no more than that, you can actually put together the platform, and you can change the width of the platform as well for different size row crops. But because it was easy to dismantle and put together with the 3 bolts, then we could easily put it into the back of a vehicle and take it from one farm to another farm and be able to represent and be able to kind of deliver on that information to the farmer. And that was what we started with. And then we thought, okay, so we can actually get some information. So you can see there's a little box underneath it, or that's where it's collecting sensory data. But we needed something a little bit more ubiquitous, something that could be seen anywhere around the world in terms of sensing. And so we thought, what would happen if we change the sensory system to make it easier for the farmer to use? So what we decided to do was use smartphone technology, because a smartphone you can buy anywhere around the world. It's got excellent computing power. It's got a camera that is getting better and better in terms of resolution. So what we did was we took a smartphone, you buy an off-the-shelf gimbal stick, and that allows the smartphone to always point down on the vegetable crops as the robot's moving along. And we put our AI algorithms on the smartphone, so as the platform's moving up and down, we can collect data, light, and the camera information, etc. And then we can run our AI algorithms in real time as the robot's moving along, and we can detect individual plants and individuals all on the smartphone. So our first real demonstration of this technology was in Bandung, in Indonesia. We got the opportunity to work with a cooperative there to actually see what would happen and how we would interact with the farmers. Lots of workshops were done. You can imagine the technology is one part, but the socio-economic introduction is kind of the important part. So understanding how to work with the farmers was important. So we had lots of workshops on what was important.
We are starting back up in the auditorium.
I'll just wait for that to finish.
Make your way there immediately.
So being able to work with the farmers, and there's lots of things that we learned. Exactly like what we have in Australia, for example, or many first world countries, is lack of labour, high labour costs, and that was an important part. But more importantly was the fact that they grow different types of crops all at once, because it's almost like a risk exercise. Which of these plants are going to survive by the end of the production season? And looking at weeds and plants detection and diseases, it was an important element. So those were the key findings and what we needed to work on. So it was a logistics issue. So how do you pack a robot, take it across? Then we got to Bandung. How do you put it together, show the farmers the kind of different operations, being able to piece this together quite easily, going from farm to farm, putting the selfie stick on there, and then starting to collect some information from there. In this first trial, we were limited to just being able to collect vision data, and that way they can, when you log the vision data, you can then come along and show the farmer, and the farmer was the most experienced at collecting the information. But there were two things that we learnt from that trial that the farmers found were necessary. One was they wanted to extend the capability so they could add their own tools on the back of the robot. So that was one part. And the other part was the logistics element. So if we went across 10 different farms in one day, what was the best way of being able to configure the robot so we can go from farm to farm easily? So that was the first thing that we wanted to do, was build a tool, and that tool can sit on the back of the robot, and then you can add different things. So this is what it looks like now, and that's what the configuration is over there. But basically you have a robot now, it has an auto hitch, they can add different tools onto the back of the robot. Now we have the smartphone working in real time, so it can collect information about each individual plant, and we can present to the farmer now information such as yield estimates, as well as where the size of the plant and potentially the weight of the individual plant as well, so yield estimation. And the farmer can now add tools onto the back, so a spraying tool is something they can add, as well as a planting tool. So these were two different tools that the farmer could actually add onto their robot. So that was the first thing that we did, and that allowed the farmers to kind of add their own tools. This is like, for example, a push seeder, and being able to add it onto the end of the robot. The second learning that we had was about logistics, and you can imagine when you're going from farm to farm, how do you pack a robot? How do you wash a robot down before you go from one farm to another, biosecurity issues and washing down a robot? But then you're dealing with very different terrains and different levels, and each farm has a different row width as well. So you go from one farm to another farm and you have to change the row width. So we redesigned the platform. The farmers were asking for longer life on the robot, so having more hours to run the robot. So there's an extension to this robot's platform. So this robot now is very easy on farm to compress and elongate. And so that allows us to kind of make it smaller and wider very easily. It's also designed so you can get a hose and just wash it down, scrub it down very easily. It makes life a lot easier. And we can also add the auto hitch, and because it's got a battery now that's much bigger, it can operate for a lot longer with a lot more power. And more importantly, it made it easier for us to be able to come along and put it on the back of a vehicle. So let's see if this works. Yep. So you can now put it onto the back of a vehicle quite easily with some ramps, and you can take it from a farm to a farm and wash it down. So we had funding from the Australian government to take it to Fiji and Samoa to kind of test the operations on that part and learn from that. So this is one particular trial where we went on 3 different farms across the terrain, 3 different types of solutions, and being able to demonstrate what could happen. So it's just in a hitch, you can just take it onto the back and forth of a vehicle quite easily. This is the dolly system underneath, and you'll see it. It's very easy. They just can push it and pull it so they can make it wider and smaller. And then that goes on to different size crops and different size crop beds as well. And being able to demonstrate collection of data, the machine learning algorithms, how they operate and how they work, and doing crop analysis as well. So this is an example of the farmers adding their own tools just to be able to do things like weeding. They would normally do this by somebody holding something and moving along, and just adding that onto the back of the robot was easy. This is the planter, being able to put that onto the platform. That auto hitch that you see here, which is controlling the planter, it's adjusting the height of the planter as the robot moves along, so it's measuring the process there. This was in Fiji, so just showing you again the ability, kind of the terrain that you have to deal with, moving the robot from one farm to another farm, and being able to operate in that space. So slightly bigger farms, but the same process, just an auto hitch. It fits inside a normal crate that fits the standard size crate, so you can compress it, standard size crate, fly it to another country quite easily. Slightly different operations here, more interested in spraying and being able to kind of run the robot on different farms. But again, collecting imagery information and spraying for crop intelligence. And this is just showing you the auto hitch and the ability for them to kind of go on different tools on the back. And a comparison, I guess, for what happens. So hopefully what I've shown you so far, I showed you the challenges before, but hopefully now I've shown you kind of the positive elements. There's been lots of different activities there. The technology is one part. We're working a lot with partners now in different countries about how to kind of bring this into a longer term pilot study. So if you're interested, please come and talk to me. There's areas there around sustainable implementation, and I'm going to talk about that next. But now we're starting to get some more interest from different countries. So the red is where we've operated, but the yellow now is some areas that some of the more countries are kind of interested in. We're starting to work with some of the governments there to look at what it means to do a pilot study. And really what they're interested in, if you kind of see the evolution, is when you go to a developing country or a smallholder country, you have to deal with the socio-economic fabric and the education elements there. So what they're interested in is how we can take our commercial and our smallholder farmer technology and build a platform that can be both manually driven or remotely driven, but also autonomous. So it has the flexibility of going from remote to autonomous, and we can develop that as well. And the last thing, and so that's really where we're working on now, is being able to develop a manually driven, remotely controlled, as well as autonomous platform. And the last slide that I wanted to say was that no matter where we went around the world and where we were demonstrated, the biggest thing that we've seen is how the younger generation is now more interested in agriculture because of the fact that the technology is there. So we've developed an education program for high school. It's about a 100-page document that talks about the robot and how you can program the robot, and it's very easy programming. They don't need to go into detailed programming. They learn about AI, they learn about GPS, they learn about autonomy, they learn about robotics, and then they get to work on the robot as well. In Australia, we were funded by the government to build 4 of these robots and put them around some rural schools, leave it in the school for about 6 months, and they get to program the robot and run it on their farms there. So we think this is not only a good opportunity for current farmers about how to use AI and so forth, but also about sustainable evolution of the robot in the local region. And hopefully what you can see here was we're trying to democratize precision agriculture. That's what the focus is on, and being able to develop that for all smallholder farmers. So if you'd like to know more, please come and visit me at the stall. More than happy to answer any questions, and thank you for your time.